Alright, we're going to do an alternate method for this light sensor and this flashlight. Currently we're using a bunch of if-else statements to set the value of a flashlight, but it's incremental. It goes up by 25s every time. The last one goes up by 27 in terms of brightness. But we can actually make it so this has 127 different values based on your light sensor, and we can do that by doing what's called a proportional loop on this. So let me kind of explain what that is. If we set up a graph where we look at brightness versus the light sensor value, we can set up axes for each of those, and our brightness ranges from 0 to 127, and our light sensor readings are from around 100 to 850. And we could set up a graph to then determine what that brightness is going to be. So let's say that we have a minimum threshold, but we don't want that light sensor to turn on until about 400. So essentially from 0 on our light sensor to 400, we don't want that light sensor to be on. And then above 800, we want it to be on full brightness. So here is 800, and anything above that is going to be full brightness. And now, anywhere between 400 and 800, we're going to have a range. We're going to have a linear pattern that this is going to follow, just like this. So now we can actually turn this into 3 if-else's. We could say that if it's in this range, set brightness equal to 0. If it's in this range, set brightness equal to some equation that's based on the light sensor. And if it's in this range, set the brightness equal to 127. So we're going to take our multiple if-else's into 3. So again, we have if the light sensor is less than 400, then we're going to say that the brightness, so we're going to set up a brightness variable, is equal to 0. And then we could say else, if the light sensor is less than 800, now the brightness equals some equation that we don't know yet. We're going to write that equation. It's going to be the equation of this line, actually. And we can do that. We know how to write equations for lines using slope-intercept form, which we'll get to in a minute. And then we're going to do else. And again, if it's not less than 400, not less than 800, it's anything else. We're just going to say the brightness equals 127. So it's full on. So now what we need to do is solve for this equation right here, which isn't that tough. We have 2 points. So we've got this point, and we're finding the slope of that line. So it's really quite straightforward. First, we're going to find the slope. So the slope is the change in y over the change in x. So the change in y, we're going from 0 to 127. So 127 minus 0 over, we're going from 400 to 800. So final minus initial. So we have 800 minus 400. So the slope then, if I calculate this, is 127 divided by 400. And I get a slope of this. Now what I typically want to do is convert this into a fraction. That's fairly common. You could do 3175 over 10,000. That's a little ridiculous. We can just kind of estimate. Again, it doesn't have to be perfect to do that. I mean, we can kind of fudge the number, and if it comes out this way, it's okay. It doesn't really make a difference for us. We'll show you how to kind of compensate for that. So this is roughly 31 out of 100, and that's pretty close. Or we could round it so it's 32 out of 100. So we could say the slope is 32 out of 100 for that line. So if that's our slope, we want to find what the y-intercept is. And the y-intercept will be way down here where it crosses the y-axis. It's going to be a negative number, so we need to figure out what that is. Or we could plug in the value 400, and what should the y value be at 400 for x? It should be 0. So we can use this data point to then figure out what that should be. So if you remember from algebra class, we have y equals mx plus b. We know that y is 0, m is going to be 32 over 100, and x is going to be 400. So we want to solve for b. So let's substitute, or let's solve for b. b is going to be equal to, if we move it to the other side, or we move this over to the other side, it's going to be negative 32 over 100 times 400. So I basically have 4 times 32. I get a negative 128 for my value. So now I have all of the things I need for my equation. Y is equal to the brightness, that's on my y-axis, and x is equal to my light sensor value. So my equation is going to end up being, if I look here, I've got y equals mx plus b. So I have the brightness is going to be equal to 32 times the sensor value of the light sensor divided by 100 minus 128. You're asking, why did you not do 32 over 100 first? Well, because brightness is going to be an integer. And if I take 32 divided by 100, it's going to give me an integer value of that, which is 0. And that's a problem. It's going to take 0 times this value, and my answer is going to be negative 128. So I want to take this times the sensor value and then divide by 100. Now, here's where I caution you, is that if your sensor value, remember, integers can only hold up to about 32,000 for their value. So if you have 32 times 850, you're getting close to that maximum value that can be stored in an integer. So right now I think we're okay. And then when we divide by 100, it gets to that. And if I subtract 128, we're good to go. Okay? Now, let's make sure that 800 doesn't go outside the bounds. I don't want this to go over 127 for a value. So I need to check that with 800, because that's the maximum value that I'm going to see here that comes in based on my if-else statement. So I'm going to take 800 times 32 divided by 100 and then minus 128. And I get 128, so this is a problem. That I get a value of 128 there, because if I plug in a value of 800, it's going to go beyond the bounds of what this can or should be. So there's a couple ways that you can deal with that. One is you can deal with it by setting another equation right after that brightness. And you can do an if statement that if the brightness is greater than 127, we can reset the brightness. We can say brightness equals 127. So that way we have an upper limit of 127 for our brightness, and it won't go beyond that. So that is kind of what we're going to do for this, is that if it goes above that number, we're going to kick it back down to 127, which is what that would do. So if 800, and actually 800 won't go into this, it would go into the else, because it's not, you could put less than or equal to 800, and that's fine, but if we just had less than 800, so 799. So if we put in 799 times 32 divided by 100 minus 128, I think it's going to, because it's an integer, it just rounds those off. So I think we're going to be okay, but this is just in case. We're going to just say if it's greater than that, throw that in there. So that's going to be inside of this else if command. It's always good practice to do that to make sure you don't go beyond your bounds. So let's put this information into robot C now. So we still want the sensor value is less than 400. This time we're going to set up a variable. So we're going to have int brightness, and we really don't have to define it at the beginning because it's going to change as we go. So now we're going to say that brightness equals 0. And then I'm going to just delete all this right now. And then we can say if the sensor value is less than, we'll do less than or equal to 800. Again, open curly, close curly. And then we'll do an else. So this is everything else. This one's pretty straightforward. This one's going to be brightness equals 127. So this is where we're putting in our equation. So here we're going to say brightness equals, and now we just type in what we said. So we have 32 times sensor value of light sensor divided by 100 minus 128. And it kind of does order of operations, or it pretty much just goes straight across on this. So it's going to do 32 times this, divide by 100, and then subtract 128. Now we can put another if statement in here. We can say if brightness is greater than 127, this will reset our brightness value to 127. So again, if it's, you could also say, in this case, if brightness is less than 0, this isn't a bad thing to do either. Say brightness equals 0. So that way it keeps brightness in the bounds of 0 to 127. If it goes beyond it, above it, it'll reset it to the max. If it goes below it in a negative, it'll reset it to the min. So again, those two if statements are just inside of this else if. This is the only time we're concerned about brightness being above and below what it could or what it should be. This, we're just setting it equal to 127. This is, we're setting it to the low value here. So now that we have this if else if statement, we now need to turn on the flashlight. So we will always be turning on the flashlight after this if. So before this while right here, we're going to find the value of brightness, and now we're going to turn on, or turn flashlight on, flashlight, and now instead of a number, we're going to say turn it on at brightness. I'm going to zoom out so you can see all the code here. So again, we have a brightness integer. Goes in. We have an infinite loop. If the light sensor is less than 400, so it checks my light sensor value. It sets the brightness value to 0. It skips the else if, skips the else, and it turns the flashlight on at a value of 0. Okay? Which means it's off. If it's greater than 400, or let's say it's 400, then it goes into this, and it calculates what brightness should be. So it does a calculation. It takes 32 times 400 divided by 100 minus 128, and that value is 0. And then it checks, is brightness greater than 127? Nope, skips it. Is brightness less than 0? Nope, skips it. So brightness is still 0, skips this else, and it turns the flashlight on at a brightness of 0. So at 400, it's still at 0. Let's bring it up to 500. So it goes into this if part. We're going to take 32 times 500 divided by 100 minus 128. I get a value of 32. So now it says, is 32 greater than 127? No. 32 less than 0? No. So it skips that, skips the else, and it turns the flashlight on at a brightness of 32. Alright, try this out and see if you like it. I think it's a different way to approach a brightness level. And again, every light sensor value is going to give you a different brightness level. So now you're going to have values from 0 all the way up to 127, and not just those increments of 25, 50, 75, 100, and 127. So enjoy.